How's it going, everybody? In this video we are going to do some lab maintenance by flipping all of our interfaces from VLANs and trunking. We're going to keep the VLANs in place because we're going to be using them in another video, but we're going to flip all of our trunk links from trunks to routed links. So we're going to be issuing a lot of no switch port commands and doing some basic IP addressing, and then we're going to go ahead and deploy Ospf with all of the network types being set to point to point. So that's going to give us two enhancements. Number one, we're not going to have any type 2 LSAs. No designated router election is going to come into play. We're also going to eliminate the limit the database. So it's going to give us more of a it's going to increase the capabilities of the protocol, meaning that we're not going to have to wait for the adjacencies to pop up and all the good stuff that goes along with that. So there's not going to be the DR aspect of things coming into play. Configuration wise, pretty straightforward stuff. The IP addressing will be relatively straightforward. So let's go ahead and actually get started with that. So let's jump over to the topology and let's begin. So to begin the configuration, we're gonna do the connectivity between our devices first, which should be pretty simple. I'm going to go ahead and go to global config, type in interface E1/1 through 2, and type in no switch port, which will convert it to be a routed port. And I'm going to do that on the rest of the devices as well. Go ahead and log into admin and add, or this one here's a. I was a dodo bird when I went to go set up the admin password, and it's actually password. But I'll go to global config interface E1/1 through 2 and type in no switch port. And then on interface, go ahead and log into all of them real quick. Go to global config interface E1/1 through 4, no switch port. And then same thing on this guy as well. I'm going to do 5 and 6 as well since I'm right here. Interface E1/1 through 4, no switch port. And admin and admin. Interface E1/1 through 2, no switch port. And then on 6, same thing. And host name is going to be Nexus 9K6. Interface E1/1 through 2, no switch port. Alright, going back over here. Now that we have that in play, we're going to have to go ahead and IP address. So we're going to type in interface E1/1. The IP address here will be 10.1.2.1/24. We're going to go ahead and do a show interface status real quick just to verify if we have, and they're both set to disable because we changed the mode from trunk or switch port over to a routed interface. So we're going to have to type in no shut to bring the interface online. Interface E1/2. IP address here will be 10.1.4.1/24, no shut. And then it's basically just going to be a wash, rinse, and repeat of all that. 9K3, same thing, interface E1/1. IP address here will be 10.2.3.3/24, no shut. 1/2 will be 3.4.3, and no shut. Now, I'm not doing the loopbacks as of right now, but actually, you know what? Let's go ahead and just do the loopbacks. Interface loopback 0. IP address here will be 10.0.0.1/32. Show IP interface brief. Perfect. We're going to go over here to 9K3. Interface loopback 0. IP address of 10.0.0.3/32. Spine 1. I'm going to type in interface E1/1. Actually, let me do 5 and 6 real quick. 5 and 6, we're going to do interface E1/1. IP address here will be 10.4.5.5/24, no shut. 1/2, same thing. Oh, wait a minute, do I not have a... Oh, whoops, that's the wrong interface. My bad. So in this one here, we're going to go ahead and set this one to be 2.5. So 1, that'll be 2.5. And on 1/2, that'll be 4.5. It's like, oh, did I make a mistake? Nope, I'm there. No, shut that one. And interface loopback 0, IP address here will be 10.0.0.5/32. And then on Nexus 9K6, interface E1/1, IP address here will be, address of 2.6.6/24, no shut, interface E1/2, 4.6, like so, and no shut, interface loopback 0, IP address of 10.0.0.6/32. Alrighty then. Now let's jump over to the spines. We're going to type in interface E1/1, and E1/1 will be, IP address here will be 10.1.2.2/24, no shut, 1/2 will be a 2.3, so 2.3, no shut that one. Interface E1/3, this will be a 2.5.2, like so. Perfect. And then E1/4 will be 2.6, and no shut. And then interface loopback 0, IP address here will be 10.0.0.2/32. Alright, so show IP interface brief. Excellent. And then same thing on 4, or Nexus 9, or the spine 2. So interface E1/1, IP address here will be 10.1.4.4/24, no shut. 1/2, 3.4, no shut. 1/3, 1/3, and 1/3 will be 4.5, 4.5.4, no shut, and then 1/4 will be 4.6, no shut, interface loopback 0, IP address of 10.0.0.4/32. Show IP interface brief. Alright, so that is that. We have all of our IP addressing done. So at this point in time, you would, if you have the membership, you'd be able to download the config guide, which the notepad doc. It's just going to be the initial config. That'll just literally be a notepad copy and paste of this config. You just dump it into your lab and you're good to go. Let's go ahead and now work on the OSPF aspect of things. So on all these devices, I'm going to go through them individually. It's going to be feature OSPF, because OSPF, if you were to do a router and question mark, nothing here. Router IP, multicast, there's no router stuff turned on. So we have to turn on feature OSPF. Hit the enter key, and then it's going to basically tell us that we don't have any licensing. So we don't have the LAN Enterprise Services Package license installed. No harm, no foul. We're going to go ahead and get all that config dumped in. So it's going to basically go to a honor-based license. It says that right there. So if you don't have the right licensing, they're asking you to go and get it. But in this case here, we're in a lab. We're not going to go spend any money on licensing. So feature OSPF is turned on. I'm just going to do the same thing on every other device as well. Feature OSPF. Could I do a command window and send it to all devices at the same time? I could, but I'm not going to. That's spine 2. Oops, feature OSPF. Feature OSPF. Alright, now that that's all done, next thing for me to go do is to configure the interfaces for OSPF. So that's going to be a literal interface E1/1 through 2. And now that we've enabled the feature, but actually before I do that, we need to turn the process on. So it's going to be router OSPF 1, which is the process ID. You don't have to use a number. If you want to use a name or something, you could. I'm going to go ahead and use a number. And we're going to go ahead and with the router process turned on, I can now go to interface E1/1 through 2 and type in IP router OSPF1 area 0, which is, for those of you that have a iOS router background, this is the interface variation of enabling OSPF. You can go underneath in iOS, in iOS XR or in iOS XE and iOS, you can go under the global process and type in a network command, enable OSPF on every interface that starts with X. That works fine, but in this case here, we're not going to do that. We're going to go and do the interface level config. That's how Nexus deploys it. So got that, and then interface loopback 0. Now the cool thing here, I'm going to show you a little cheat option here. You can do a show CLI unformatted, or I'm sorry, history unformatted for pipe the last 20 lines, right? And the cool thing about this is it gives me everything that I need. If I was to go, I don't know if I can go back further than that. Awesome. I can literally go back to the last several commands that I've typed in. I'm literally going to take these few commands. Actually, did I do? Okay, I didn't do the loopback yet. Underneath loopback 0, IP router. So let's do the last 25 commands. Let's do 30. See how far back it'll let me go. It'll let me go back to the very beginning. Okay, cool. So I can literally take the, let me do this. Let me go to Nexus 9K3 and do this, because it'll be a little cleaner. So I'm going to go into, I've turned feature OSPF on. I'm going to type in interface router OSPF1, turn the process on, and then interface E1/1 through 2, IP router OSPF1 area 0, and then interface loopback 0, IP router OSPF1 area 0. So show CLI history unformatted for the last 8. So I can literally take all these commands right here and drop them onto spine, or I'm sorry, 9K5 and 9K6 respectively. And that's really where the winner of this piece comes into play. Spine 1, it's going to be router OSPF1, and then interface E1/1 through 4, IP router OSPF1 area 0, and then interface loopback 0, just like that. And we do show CLI history unformatted for the last 5. We're literally, whoops, let's go and do the last 8 or 9. And router OSPF and do that. Go to spine 2, same thing. Excellent. So now that's there. Now that's going to be the last little bit that we're going to have to work with. The next thing we're going to go do is enabling the point-to-point process. So let's talk about that real quick before we dive into it. What does that mean by using point-to-point? Well, normally OSPF on an Ethernet enabled interface is automatically going to default to the network type of broadcast. Broadcast is going to leverage a type 2 LSA. It's basically an optimization where the idea would be you can have more than 2 OSPF neighbors on a particular physical interface. So you might connect more than 3 or 4 routers to the same LAN segment, same subnet, and potentially want to do multi OSPF peerings over that particular multi-access interface. Meaning you go leave out one interface, but there's multiple destination IP or MAC address connections that you can reach out to. No different than if you were to take a router, plug it into a switch in VLAN 10, and plug in router 2, 3, 4, 5, and 6 into ports on that same switch in the same VLAN, and they're all in the same subnet. They're able to communicate with one another, and once you're able to communicate back and forth with each other, then you can form multiple OSPF adjacencies. In a situation like that, when you're dealing with that, not every host or not every router should be sending all of its updates to every other router, which would be a full mesh type of design. OSP, to mitigate that, which was originally developed basically to deploy OSPF over a frame relay network, or a multi-axis environment where you would have like a hub and spoke kind of a scenario, where the hub would be the DR, the designated router, and all of your communication would communicate between the spokes and the hub. It's supposed to optimize things. It worked out pretty well, and if you've never dealt with designated router elections and things like that over a WAN, it's not terribly difficult to understand. Basically, your spokes get a DR priority of 0, and your hub gets a DR priority of 255, so you're guaranteeing the hub router, wherever it might be, is always going to be the designated router. Not the greatest solution out there for doing a hub and spoke type of design for the WAN, but it does get the job done. So essentially what we're going to do here is we're going to eliminate the type 2 LSA, which is the DR LSA. We don't need to have a designated router when there's only 2 connections, so a spine and a leaf connected to every physical interface. So to fix that, we are going to basically set up each one of the links between each spine and each leaf isn't going to be a multi-access connection, meaning 2 or 3 or more potential Ospf speakers on that subnet. We're only going to do 2, spine and a leaf per physical interface. So we're going to flip that over to be a point-to-point connection. But Rob, you've configured /24s. I have, because I'm just lazy and I don't feel like doing the subnetting. So it's just easier to do it this way instead of having the same subnet over and over and over again and just do point-to-point links. This makes it easier when I'm looking at my routing to know that I'm dealing with spine 1 and 9K3. So it just makes it easier to do that way. With that being said, let's go ahead and jump back over to the config. And the cool thing about this is we can start on 9K1 and we can type in interface E1/1 through 2 and type in IP OSPF network point-to-point and hit the enter key. So we're literally just going to take this command right here and we're going to deploy it on interface E1/1 through 2 and copy paste. And hit the up arrow a few more times, go underneath all the interfaces and paste. Makes it very, very easy to roll this out. And then we're going to go ahead, and actually before I do that, if we do a show IP OSPF database, what you're going to see is a lot of this. This is what they mean by the type 2 LSA, or the network link state LSA. If you don't have a deep understanding of how OSPF works, this might be a foreign topic to you. But basically what you're basically doing is whoever becomes a designated router there's going to be a pseudo node. And the pseudo node is going to be an imaginary router that's sitting on the LAN segment between 2 different devices, so 9K1 and the spine one. And what it's basically doing is it's saying, I have visibility to 2 different nodes on the network. I have visibility to 9K1 and spine 1 on 10.1.2.0/24. Because I have visibility to both nodes, I can send and receive updates from either one to the other. And that works out really, really well. Again, the whole purpose of the designated router is to optimize the control plane operations in a multi-access environment where you've got 3 or more routers. I say 3 or more routers on a link. You need 2 at a minimum, but typically this is designed for 3 or more, where you don't want to have every OSPF speaker sending and receiving all of its updates to every other speaker. It doesn't make sense to do that. BGP does this in a full mesh design, which is why a lot of times people will deploy a route reflector to minimize that type of control plane updating. So in this case here, we're doing the same thing. The designated router is a route reflector. We're getting rid of that because we don't need it in our environment. So I'm going to go ahead and hit the up arrow real quick. And let's go back to spine 1, grab this line real quick. And spine 2, and interface. There we go, and do all that. And so as soon as I do that, I'm going to start losing all these connections here in just a couple seconds. So 9K5, drop that command in like so, and then 9K6. And then copy paste just like that. Okay, so go back to spine 2, hit the up arrow, and my network link states will eventually start to fade away. And the idea, once they fade away, I will only have router link states in the network squared away. So not sure why these guys are hanging out here. There we go. So now it's just type 1 LSAs. If we come up, hit the up arrow, now we just have type 1 LSAs. The router LSAs, everything else is gone, which is exactly what we want to have. All right, so now that that's done, that's our optimization for Ospf. So we've done that to everybody. So just a quick recap of what we did. We went through, we converted all the interfaces on the devices from switch ports, trunking between the switches, to a routed interface, and we configured the IP addressing on that. And then we deployed Ospf, turned the feature on. We deployed Ospf on all the inter-switch connections as well as the loopback addresses, so we have reachability. If you want to just verify that real quick, on spine 2, if we show IP route Ospf, we're going to see a lot of Ospf routes. We should see every one of the other loopbacks. So we should see 1, 2, 3, 5, and 6. We're technically spine 2, which is Nexus 9K4, which is why we don't see .4 here in Ospf. And then we can see all the transit interfaces as well, which is what we want. So that means that everything's working the way that we had expected to, which means that the network is operating the way we want it to. So with that being said, that's everything that we've done in this video. Check if you're a member, make sure to check the members section, the folder, to get the configurations. If you want to just copy and paste this in and you want to mimic the lab, by all means go ahead and do that. Until next time, guys, take her easy.